In this second video, we're going to provide an understanding and review some of the core fundamental principles involved in quantitative methods. And the first step here is to understand the difference between a population and a sample. And so when we talk about a population, we typically refer to an entire group of individuals to where some law of nature applies. And some examples here might be all university students in Canada. Could also refer to all Canadians over the age of 65, all Canadians suffering from arthritis, or all people with cardiovascular disease. And so if this is something we're interested in understanding, then we take approaches and develop what are called parameters. Parameters is applying numerical values to characterize the population, and whatever that population that we define. And so to characterize different characteristics of this population, we use Greek symbols. And so these are the symbols that we'll use throughout the course that you'll see repeatedly. So Greek letter mu refers to the mean of a population, or just simply the average of the population. Sigma refers to the standard deviation of the population that we'll define throughout this course. And so when we talk about the standard deviation, we're referring to a numerical value that describes how spread out the scores are within a given population. Greek letter rho refers to the correlation coefficient. And so you'll see some additional Greek letters, Greek symbols used throughout the course. And whenever you see a Greek symbol, it's making reference to an entire population. Now, in reality, our access to the entire population is not very realistic. And so to gain an understanding of the characteristics of the population, what we do in research is we obtain a sample. And that's a small subset that represents the population. And so if we are interested in all university students in Canada, we reasonably can't test and draw information from every university student in Canada. So we obtain a sample. And so what we'll do here is we might randomly select and solicit feedback and information from 50 undergraduate students at the University of Guelph. And from these 50 students, we generate what are called statistics. And so statistics are numbers that characterize the sample. And we use English symbols to represent this. And so we see the counterparts to the population parameters. X with a bar on top signifies the sample average, or the sample mean. We'll use those terms interchangeably. SX refers to the sample standard deviation, and R refers to the sample correlation coefficient. Now, again, when we talk about a random sample, we're talking about individuals that make up the sample randomly selected from the population. And this is something that, when we deal with humans, is really in theory. The problem with a random sample is that it may not produce a representative sample of that population. So in reality, it's very difficult to randomly select people to study. And we'll take a look at the reason for this in a subsequent video in Unit 1. So when we talk about applying statistics to research to characterize the observations that we make, we establish what are called variables. And so we have two major types of variables. We have what are called qualitative variables, and these types of variables do not use numerical descriptions, but uses different classifications to identify the characteristics of different people or from what we're measuring here. In this course, our focus will be on the quantitative aspect, where we actually use a number to represent that information obtained from a research participant, and that indicates the amount of, or the magnitude of the observation from the information that we gathered. So an example here might be standing height. If we wish to gain information on the standing height of students at the University of Guelph, we can take a quantitative approach, and if we take a quantitative approach, we'll track height in units of centimeters or inches. But we could also describe height in qualitative terms. So we might have 3 different categories: tall, average, or medium height, or short. But to establish these qualitative categories, we have to define criteria to which a person would fall within those different qualitative areas, those qualitative descriptions here. Another example here might be political election outcome. And so if we take a quantitative approach to gather the outcome of a political election, quantitatively we'll count how many seats are in the legislature from the different parties that run in an election. Qualitatively, we might describe the outcome as which party is in the party that's in a majority government, a minority government, the official opposition. And so what we do here, once again here, to establish a majority or minority government or the opposition, there are strict criteria in order to make that classification. Now, to get a little bit more detailed in terms of the quantitative definitions and the quantitative things that we'll be touching on, we made reference to this term earlier, data. And I described data as basically information that we gather. But when we use the term data, we are making reference to numerical descriptions. And so these are what are called scores on different variables, and the information expressed as numbers. And so variables refer to traits that can change values from case to case. So gender could be a variable, age, religious affiliation. These are all variables that would have different descriptions depending upon the case that fits under that variable. Cases refers to entities from which the data are gathered. So we might gather information from people individually. If our study is focused on local businesses in the city of Guelph, then we would draw information from local businesses. The same with different cities. If we want to compare housing prices from Guelph to Kitchener to Toronto to Kingston, then we would draw information in order to compare those different cities. So each city would be a case in that situation. Now, in terms of applying these key concepts, a scenario here that we'll just go through shortly. In a recent survey of university students, Statistics Canada found that the average age of university students in Canada was 21.7 years. And so if we try to identify the following, we ask, what is the variable here? And so what we're examining here are university students, and what was tracked by Statistics Canada is the average age. And of course, the age of each university student was measured, making age the variable. The data are the actual cases that represent here in this case. And the cases are university students. And so in this particular situation, the data refers to the average, 21.7 years. There are two other approaches that we take in terms of statistical applications or quantitative measures that we'll focus on throughout the entirety of this course. And the first approach is to generate what are called descriptive statistics or descriptive data. And these are values, numbers that describe the basic characteristics of a person or a group. We can summarize one variable, such as age. So if our interest is the average age of students at the University of Guelph, we would describe that study as being univariate, one variable. There are approaches where we can examine the relationship between two variables. So if we collect information from students at the University of Guelph on age and major that they're focusing on, their course of study, then we have two variables in that study. So we would say it's bivariate. Now, if we sample age, major, and grade point average, now we have three variables. So anything above two variables we just refer to as a multivariate study. Now, we generate descriptive statistics in order to make inferences back to the population. So recall, we always identify a population that we're interested in studying. The population might be all University of Guelph students, but it's very difficult to, and not very realistic to sample all University Guelph students. So we obtain that sample. From that sample, we generate these statistics, and we want to make conclusions back to the population of interest. And that's what the statistical approaches in this course will address. So inferential statistics are calculations that infer the results back to a larger population. And we do this through something called hypothesis testing. So we have two different hypotheses that we're going to define in this course. There's the first type that we defined in the first video, which is just generally the hypothesis. That's referred to as the research hypothesis, which is the educated guess. The type of hypothesis that we'll use in this course is something called the statistical hypothesis, and that will be defined further as we move along. Now, inferential statistics also involves descriptive statistics as well. So you can generate a study where you generate descriptive statistics and stop there. And that might just be the interest of that particular study. But if one wishes to infer the results back to the population to which the sample was obtained, then we would have to use the inferential statistical techniques that we'll discuss throughout the course. And the inferential techniques typically establishes what's referred to as cause and effect relationships between variables. If situation X occurs, it will cause situation Y. So this ends our second video of our introductory unit.